We'll now talk about graph terminology and special graphs. So if we have an undirected graph, we say two neighbors are adjacent if there's an edge between them. The edge is said to be incident with the vertices. So any vertices that are connected by an edge are adjacent, also known as neighbors, and then the edge is said to be incident. The set of all neighbors of a vertex is the neighborhood of V. It's denoted by n of V. So for example, if I look at this vertex here, these two would then be the neighborhood. So if this is V, these two vertices would be n of V. If I considered this one to be W, just this vertex here would be n of W, since it's the only one that is adjacent. So the number of edges that are incident to a particular vertex is said to be the degree of the vertex, denoted by deg of V. And a loop actually contributes twice towards a degree, mainly because it does intersect this vertex twice, once as a starting point and once as an ending point. We say a vertex of degree 0 is isolated. So for example, this vertex here would have degree 2 since it has 2 edges. This one here has 1, 2, 3, 4 edges, so it would have degree 4. This one just has 1. This has 1, 2, 3, 4, 5, since the loop counts twice. This one will have 2, and this vertex here is said to be isolated since it has a degree of 0. With the directed graph, we'll say that U is adjacent to V when there is an edge from U to V. So it's only adjacent if you start at the first point and then end at V. We have two different types of degree with directed graphs. The end degree of a vertex is the number of edges with V as their terminal vertex, denoted by deg to negative of V. And then the out degree is the number of edges with V as their initial vertex. So this is deg plus V. So for example, this one, if I look at the degree n, I look at the edges coming into the vertex, which is 1, 2, 3. The out degree would be the number of edges leaving the vertex, which is 1, 2. If I look at this one here, the degree n would be the number of edges coming in, which is 1, 2, 3, 4. And then degree plus would be the number of edges leaving, which is 1, 2, 3. We do have some graphs that are special graphs here that have special names. So the complete graph on n vertices is denoted by Kn. This is a simple graph that contains exactly one edge between each pair of distinct vertices. So for instance, this is K2, K3, K4, K5, and K6. Like I said, the idea is any two vertices will have an edge between them. A cycle, any greater than or equal to 3, consists of vertices that are connected in kind of a circle. So it's kind of just the outer shell. This right here would be C3, C4, C5, and C6. A wheel adds an additional vertex to our cycle graph and connects this new vertex to each of the vertices in Cn. So for instance, here's W3 because it's C3 with an extra vertex in the middle, There's W4, W5, and W6.